How many n-bit strings are possible without consecutive zeros? So, in this question, they are asking you to find out the number of n-bit strings possible, binary digit strings of length n, but you must not consider those cases where there are consecutive zeros. What do we mean by that? Consider this to be a binary string of length 8, right? But you see there are 3 zeros in middle, consecutive zeros, and hence this is not a valid possibility according to the question. Consider this as another string of length 9, but here there are no consecutive zeros, right? This is a valid possibility. We are not bothered about whether there are consecutive ones or not. We are only bothered about the consecutive zeros. Now, consider this one. There is no consecutive zero here and hence it is valid possibility, right? These were some of the examples. Now, supposing n is 2. For n equal to 2, what are the possibilities? Let me enumerate some of them. This is valid possibility 1 0, 0 1 is valid, 1 1 is valid, 0 0 is not valid, right? It has consecutive zeros. So we are not considering this possibility, and hence for n equal to 2 there are 3 enumerations. There are 3 possibilities of writing binary digit strings of length 2, right? Without consecutive zeros. Keep this in mind, it will be required for our further steps. Now, consider this to be your n-bit string, right? Now, as in the earlier video where we had seen just writing the possibilities for an n-bit string, I'm going to do the same thing here, but what is my t of n in this case? T of n is the number of n-bit strings without consecutive zeros. Please do not get confused with the t of n in the earlier video and this video. Here, without consecutive zeros is very important. This is an extra condition in this problem, and hence t of n is always dependent on the question. You cannot consider t of n to be always the same one in all the problems. Now, in this case, t of n is number of n-bit strings without consecutive zeros. Now, let me again do the same thing as the one I did in the earlier problem. In the n-bit string, if I start with 0, if the string starts with 0, then what can come in the next position? It can be a 1. Can it be a 0? Definitely no. How? Because we are striking off those possibilities where there are consecutive zeros. And hence, only 1 can occupy the position immediately after 0. And hence, this problem reduces to finding the number of possibilities for n-2 bit strings. Right? You have locked these positions 1 and 2 where you start with 0. A 0 cannot come in the immediate next position. 1 has to come. Only 1 can come, right? So now the problem reduces to finding out the number of n-2 bit strings, which I can write it as t of n-2. The number of possibilities for bit strings of length n-2, right? Now this is the case if I start with 0. What if I start with 1? What does it become then? In case I start with 1, anything can come in the next position. How? There are no restrictions on consecutive ones, right? So you can either have a 1 in the next place or a 0 in the next place. So now this problem reduces to finding your strings of length n-1, right? So if you write a 1, you can find out n-1 length bit strings, right? So the problem now reduces to finding t of n-1, which is the number of n-1 bit strings without consecutive zeros. Clear? Now, we move ahead and write what is T of n. T of n, we saw that if you start with zeros, there is one condition. If you start with 1, there is another condition, right? So T of n minus 1, T of n minus 2. I have written both the possibilities. T of n minus 1 is the case when you start with 1. T of n minus 2, you have to calculate this when you start with 0, right? So T of n depends on T of n minus 1 or T of n minus 2, whether you start with 1 or 0. So either of them can occur, and hence by rule of sum, there is a plus in middle, right? You might want to watch the previous video for more clarity. So T of n is given to be T of n minus 1 plus T of n minus 2, and this is the recurrence relation. But can I stop here? Please note, we must always mention what is the base case. What do I mean by base case? You know that T of n is T of n minus 1 plus T of n minus 2. But if you go on like this, right, for further finding out T of n minus 1, you need T of n minus 2 and T of n minus 3, right? Where will you stop? Since it's a finite step process, you must stop at a point. So, you know that when there is only one string, one length, the string is of length 1, we had seen that there are two possibilities. Either it is a 0 or it is a 1. There is no question of consecutive zeros in this case, where the string is of length 1, right? And now T of 1 is 2 in that case. When you have n equal to 2, that is, there are two positions, the string is of length 2, you had seen that a few minutes back, you had seen that the number of possibilities are 3 in that case, right? So now these two are the base cases. So T of n equals T of n minus 1 plus T of n minus 2 is the recurrence relation for the number of possibilities of n-bit strings without consecutive zeros, and the base case for this recurrence relation is T of 1 is 2 and T of 2 is 3. Well, till now we have seen the recurrence relation. The solution of this is left as a challenge for you people. You please do it yourself, try it yourself, and if you do not succeed, it is quite okay. You will be seeing the solution in the further videos.